Greetings, everyone. Today we're going to explore solving log equations, specifically in this video using our log properties of expanding and condensing. You definitely want a calculator for this, so make sure you're ready to go. What we've explored so far is when I have a one-to-one log relationship, meaning no addition, no plus, just one-to-one. If I can get an equation simplified down to that, then we get to drop the logs and solve. See my previous videos. The other ideal situation we've encountered is when there's a log on one side. When there's a log on one side, we can convert to exponential as a way to help us solve. But today, in this video, we're going to go over what if I have multiple logs on one side? Well, my goal is I need to make it so there's only one log or a one-to-one relationship. That's the only way I can solve. So that's what we need to make our equations today. So quick review. See how this is a log one-to-one relationship? There's one log piece, nothing else. I can drop the logs, solve my equation accordingly. Now, it doesn't work if I was to place, let's say, a +5 over here. Well, now it's not one-to-one. So keep that in mind. Our goal is if it's just one-to-one, we can do that. We also have an example. We already had a video on this. If I have a single log equal to an integer or any type of value at that, we can convert to exponential. When we convert to exponential, it becomes something I can calculate. Now, more specifically for this video, you'll want to jot this down in your notes. If I take a look, I have 2 logs on one side. If I add a log over, it's not going to be one-to-one. It's not going to help. So in this case, I do want the logs on the same side. I am noticing that I have a subtraction sign. And based on our expanding and condensing video, I can condense that and turn it into division. The first piece goes on top, the second piece goes on bottom. What I have done is created a single log equation. A single log equation, based on our previous understanding, can be converted to exponential. The base becomes the base, the answer becomes the exponent. What's remaining becomes my value. All right, so let's take 2 to the third. And how do I solve it when I have an expression over an expression? Well, instead of dividing by 4 minus x, let's times both sides by 4 minus x. If I multiply it to the other side, I now have a 5 plus 2x equal to, and we need to distribute that 8 onto there. I'm going to take care of that right away. So 8 times the 4, if I distribute it in, is 32, and 8 times negative x would be negative 8x. Perfect. So once we've got that exponential form, this really is kind of going back to Algebra 1 solving. Let's move things side to side. I'm going to move the 8 over. I'm going to move, let's see, the 5 over. And I have to divide. And I'm going to just leave it as an improper fraction. Now we do want to check our answer and make sure it's allowed, meaning I can't take the log of a negative number. Well, let's see. 27 divided by 10 would be about 2.7, right? Will 4 minus 2.7 get me a negative or a 0? Nope. Well, 5 plus 2 times 2.7, that would be good. It'd be a bigger number. Now, if I wanted to check completely, then use all the functions of your calculator, but I know it's a possible answer. Let's take a look at this one. Jot this one down in your notebook. I have, again, 2 logs on one side. So I need to convert them into 1 log on one side. I see it's an addition symbol with a base of 4. Addition becomes multiplication. So I'm going to multiply my 2 values. That gets me to a value of 8x squared. We can now convert because I have a single log. 4 to the third equals 8x squared. Well, let's see, 4 to the third is 64. If I divide that 8 over, right, so instead of timesing it, we got to divide it over, that gets me 8. Then we need to square root both sides. X equals the square root of 8. And then don't forget we're solving, so it's a positive and a negative. And we got to reduce the radical. Square root of 8 breaks down to 4, 2, which becomes a positive and negative 2 square root of 2. Now we have to check, can I have a positive, can I have a negative? If I was to plug it in here for this x, a positive squared would still be positive. And guess what? A negative squared, still a positive. So both are possible solutions. All right, let's take a look at this one. Now, I didn't originally have this one in my notes. Check your notes. If needed, if you have some extra space, I would encourage you to jot this down, as I realize there's some homework problems that needed some clarification. So this will be helpful here. The first thing I see is I have a log on each side, but I also have this plus 2. So it's not 1 to 1. And it'd be more beneficial if the logs were next to each other, right? So in this case, I'm actually going to kick this log to the other side. If I add it to the other side, I've created an addition problem. So I'm going to write that out a little bit better. And you don't even need to show any of this work. I think at our level, you could just easily rewrite, meaning log of 2 of x plus, because I added it over, log of x minus 5, and it would have a 2 left over. See how I kicked it over? So now I can do something, right? I'm going to combine with my condensing rules. Instead of adding, it's going to become multiplying. Well, let's see. Let's take care of that multiplication. 2x times x would be 2x squared. 2x times negative 5 would be negative 10x. We still got the log. We still got the equals 2. I have a single log, so I'm ready to convert. Technically, this is a base 10, right? This is common log. So 10 squared equals 2x squared minus 10x. Well, 10 squared, I could just change that to 100. Oh, look what we got here. I'm going to kick that 100 over. We have a quadratic that needs to be factored. I'm going to divide a 2 out. That'll make it much easier to divide, or excuse me, to factor, sorry. If I factor that, I'm going to have a 10 and a 5. Let's make it negative, positive. So my solutions would be x equals 10, comma, negative 5. Well, let's take a look. If I was to plug in negative 5 here, that'd be a negative log. Uh-oh, no good. That negative 5 isn't even a possible solution. If I plugged in 10, that'd be okay. If I plug in 10, that'd be okay. So 10 is my possible solution. All right, as always, make sure to check out Google Classroom to see what the task is. Consider rewatching the video without writing, just listening, remembering the rules. Let me know if you have any questions, and until next time, have a good one.